In this video, I'll show you how to determine whether or not two linear equations graph lines that are parallel, perpendicular, or neither. So here's a typical problem. It gives us a system of two equations that I'll let you read there, and the question that would accompany them would say something like, determine whether or not these lines are parallel, perpendicular, or neither. So to do this, we have to figure out the function's slope. So let me write that on here. The real question here is, what is the slope of each line? Because if we analyze the slope, we'll have a measure of its steepness or slantedness, and that'll allow us to determine whether or not they're the same slantedness, the opposite slantedness, or just some sort of different amount of slantedness. Now, the common mistake is to assume that the coefficient of x would immediately be the rate of change of the function. So some people will say -6 and 8 will be your slopes, but that is not true. The slope of each line is only determined by that value when y is isolated. So only when your function is in y equals mx plus b form, or slope-intercept form, only then can you read the function by analyzing, read the slope by analyzing the x coefficient. So neither function is given in this form, so we have to rearrange both functions so they're in this form. Once we have the slopes, we still have to ask ourselves, well, what to make of these two numbers that we get. So let's do a bit of a review. Lines are parallel on the coordinate plane when they have the same slope. So let's say that the slope of the red line was something like a over b. If it's parallel to the slope of the blue line, then the blue line slope would also be a over b. So if this were the case, then our two lines would in fact be parallel. Fair enough. Same slope means they're parallel. A little trickier is perpendicular lines. So let's say the slope of the red line was a over b. And the slope of the blue line we can tell is not, because it's crossing. Moreover, we can tell that it's negative because it's a downhill line compared to reading from left to right. And moreover, if the slope happened to be in this pattern of the opposite, so this is positive, this is negative, and reciprocal, this is flipped from top to bottom, right? If we have this relationship, then our slopes are indeed perpendicular. So if you have this pattern, then the slopes are perpendicular. So that's what we're looking out for. Are they the same, or are they precisely the opposite in two different ways? Positive, negative, and flipped. So let's find out. Let's take a look at the slope of each line independently. So let's look at the top function first. I'll just call that the red function for consistency's sake. So to get its slope, I need to solve for y. So I have -6x plus 16y equals 10. I'm going to add 6x to both sides to maintain balance. And that'll give me 16y, that's a positive 16y, equals, these are unlike terms, so 6x plus 10. I'm going to divide both sides by 16, and that will give me y equals 6 over 16x plus 10 over 16. I'm just going to leave that as 10 over 16. And I could leave it there, but I'll notice that 6 over 16, when it comes to rise and run and slope, these numbers are not exactly the friendliest. So if I think carefully back to elementary school math, can I rewrite that in some better way? Well, they're both even numbers, so I can probably reduce that fraction. And if I do reduce that fraction, what I really get, the best form of this function would look something like this. Divide 6 by 2, that'll give me 3, and 16 by 2, that'll give me 8. So I have 3/8 x plus 10 over 16. So the slope of the red function is this guy right here. It is 3/8. I'm going to hang on to that number for a while because I have nothing to compare it to until I find the slope of the second function, which I'll call this blue function right here. So let's solve this guy for y. We currently have 8x plus 3y equals 9. So solving this for y, I think I may have said solve for x, I apologize. Subtract 8x from both sides to get the y term isolated, so 3y equals negative 8x plus 9. Divide everything by 3, and I get y equals negative 8/3 x plus 3. The important number here for our purposes is the slope, which will be the coefficient of x once it's in slope-intercept form, which is negative 8/3. So I'm now ready to compare these two numbers. One of my slopes is 3/8. My other slope is negative 8/3. Are they the same? Pretty obviously not. So we can rule out parallel. Are they perpendicular? Well, let's see. The top becomes the bottom becomes the top. One's positive, one's negative. So it looks like we have our answer. These two lines, when graphed, would be perpendicular. Hope this helps.